Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 7. This is Section 14.2, Problem number 7. It says, after attending the seminar mentioned in Problem 6, Manny decides that he should fence in his used car lot to minimize the possibility of vandalism. So he goes over to Mid-City Steel, and he purchases 200 yards of 6-foot-high vinyl-coated chain-link fence. He wants to fence in the largest possible 4-sided rectangular area with the 200 yards of fence, like in the diagram here with the length and the width. So part A says, what dimensions will produce the largest possible area with the 200 yards of fence? So again, I add a nice diagram below the question, but essentially you have a rectangle, and the width we label W, and the length we label L. And the area is length times width. That's the area of any rectangular shape. And this is what we want to maximize. So we're going to want to take the derivative of the area, set it equal to 0, and solve for the variable. The problem is we have two variables. We have to write this function in terms of one variable before we can take the derivative, set it equal to 0, and solve for the unknown. So how can we do that? Well, the key is that all the way around is going to be the 200 feet of fence. So 200, so let me come off to the side next to my area equals length times width. And I know that 2 lengths and 2 widths added together have to add up to 200. That's the amount of fence. 2 lengths, a top and a bottom, plus 2 widths, a left and a right, have to add up to 200. Now that I have this, let me solve for one variable in terms of the other. So let me bring the 2L here over to the right-hand side with the 200. So when I do that, I'm going to have 2W equals 200 minus 2L. I just brought the 2L over. And when it goes to the right-hand side, it's a positive on the left. It will become a negative on the right. And I want W equals, not 2W. I don't want the 2 in front, so easy enough. Divide everything by 2. So on the left, 2W over 2. The 2's cancel. I have W equals. And this 2 here is going to reduce both pieces, so it's going to be 100 minus L. So now W equals 100 minus L. So now if I take that value for W and bring it back into my equation for area, I can substitute in the value for W in terms of L and write the area function in terms of one variable. So now I have area equals L times W becomes L times 100 minus L because W is equal to 100 minus L. So now I have the area function in terms of one variable. I can clear my parentheses too. Area equals L times 100 is 100L. And then L times minus L is minus L squared. And don't forget the negative. So there's a function for area in terms of one variable. So now we can go through that process of maximization that I mentioned. First, take the derivative. So I'll have A prime equals the 100L is going to make a 100. Again, because when you take the derivative, usually it's an x, but whatever the variable is, if it's to the first power, the derivative is the number in front of the variable. So in this case, the 100. And then the minus L squared has a derivative of minus 2L to the first. And again, where that comes from is my exponent of 2 comes down times the number in front, which isn't written but understood to be negative 1. 2 times negative 1 is minus 2. L to 1 less power, the second power, drops down to a first power. So now that I have the derivative A prime, I'll set my answer equal to 0. 100 minus 2L will become 100 minus 2L equals 0. And now solve for the variable. So let me bring this 2L over. 100 equals 2L. So it just goes from the left side to the right side of the equal sign. It goes from a negative 2L to a positive 2L when it comes to the right side of the equal sign. Divide out the 2. And I'll get that L equals 50. Now the question said find the dimensions that make the most area. So now that if I have L is 50, so the top and bottom will both be 50. Now again, there's 200 altogether, so I used up 50 for the top, so I'm down to 150, 50 more for the bottom, I'm down to 100, and because it's a rectangle, the remaining 100 will be split equally, so it winds up being actually a square that's 50 yards on each side. So 200 feet of fence, those dimensions of 50 on each side make the biggest amount of area you can enclose. Now, part B says, what is the largest possible area Manny can enclose with a 200 yards of fence? Now again, remembering from geometry that area equals length times width, and now that we know that the length is 50, and the width is also 50, 50 times 50 will be 2,500 square yards. So if you have 200 feet of fence, that's the maximum possible area you can enclose with it with a rectangular shape like this.